trình bày. Nam với bạn nào nhỉ? Nam Chi. Cô cho quyền chia sẻ màn hình nhé.
Nhiều em sẽ làm về chủ đề ứng dụng của laser và laser khí heli và neon. So, hello everyone. My team is team 3. We have 2 members, me, Nam, and Chi. So today we talk about the topic applications of lasers and helium neon lasers. First, Chi will talk about the applications of laser.
Chi bật cam. Chi chưa bật mic.
Xin lỗi, tại vì chuột của em nó hơi nhạy, lần 2 lần vậy thì tắt luôn. In the first class, I will talk about types of laser. We have 4 types of laser, include solid state laser, gas laser, liquid laser, and semiconductor laser. About solid state laser. A solid state laser is a laser that uses solid as a laser medium. In the laser, glass or crystalline material are used. Ions are introduced as impurity into host material, which can be a glass or crystalline. The process of adding impurity to the substance is called doping. Rare earth elements such as helium, erbium, and terbium are most commonly used as doping. Materials such as sapphire or neodymium doped helium and aluminum garnets and it's very hard to pronounce that word. Terbium doped glass are used as host material for laser medium. Out of the neodymium doped yttrium aluminum garnet is most commonly. And about gas laser. Gas laser is a laser in which an electric current is discharged through a gas inside the laser medium to produce laser light. In gas laser, the laser makes a laser state. You can see that and the mixture of gas is packed up into a gas tube. And the gas tube filled with the mixture of gas acts as an active medium or laser medium. And gas lasers are of different types. There are helium neon laser, argon ion laser, carbon dioxide laser, carbon monoxide laser, and excimer laser. The type of gas used to construct the laser medium can determine the laser wavelength or efficiency. The third laser is liquid laser. A liquid laser is a laser that uses a liquid as a laser medium. In liquid laser, light supply energy to the laser medium. A dye laser is an example of the liquid laser. A dye laser, as you know, is a laser that uses an organic dye as the laser medium. And the last one is semiconductor laser. And the semiconductor laser are different from solid-state laser. In solid-state laser, light energy is used at the pump shot, whereas in the semiconductor laser, electrical energy is used at the pump source. In semiconductor laser, a p-n junction of a semiconductor diode from the active medium of laser medium. The optical gain is produced within the semiconductor material. And now I will talk about the application of laser. And as you have known that laser has various unique properties such as coherence, monochromaticity, directionality, and high intensity. Because of their unique property, lasers are used in various applications. The most significant application of laser include in medicine, in communication, in industry, in science and technology, and in military. About laser in medicine, it can use to do some like plastic surgery, destroy kidney stone, and as we know as sỏi thận in Vietnamese, and cancer diagnosis and therapy, or we can use to do the island curvature correction, and it can also use in fiber optic endoscope to detect tumor in the intestine. Yeah, and about in communication, with the help of laser, we can use it in optical fiber communication to send information over long distance with low loss. And it also can use in underwater communication network. And last is can use another one is it can use in space communication like radar and satellite.
Yeah.
What about in industry? It can use to cut glass and quartz or trimming the component of integrate circuit. Use for heat treatment in the automotive industry, collect the information about prefixes price of various products in shop and business establishment from the barcode print on the product. And the ultraviolet laser are used in semiconductor industry for photolithography. The photolithography is a method used for manufacturing print circuit board, or we call PCB, and microprocessor by using ultraviolet light. And about in science and technology, with the help of laser, we can using it in studying the Brownian motion of particle, or prove that the velocity of light is the same on direction with helium neon gas laser, and count the number of atoms in a certain retrieve store information from a compact disk, or store large amount of information or data in CD-ROM. The last application of laser is in military. With the ring laser gyroscope is used for sensing and measuring very small angle of rotation of the moving object, and the laser can be used as a secretive illuminator for recognition during night with high precision. And the decode the energy of a warhead by damage the missile and use it in the LiDAR to accurately measure the distance to an object. And about part 2, now we'll
so talk about the helium neon lasers. First, we'll introduce to you about it some information. First, The helium neon lasers has many industrial and scientific use, and they are often used in laboratories demonstration of optics. Is a 4-level gas lasers and have user operation wavelength in about 632.8 and in the red portion of the visible spectrum. It operates in continuous working mode or CW mode. Helium neon lasers, usually called the Helium in lasers, and is a type of small gas laser. About the helium neon laser applications, the narrow red beam of the helium neon lasers is used in supermarket to read barcode, and it is used in holography in producing the 3D images of objects. Helium neon lasers have many industrial and scientific use and are often used in laboratory demonstrations of optics. And talk about the construction of the helium neon laser. First, we set up consists of a discharge tube of length 80 centimeters and bore diameter of 1.5 centimeters. And the gain medium of the laser has the name of the laser. We use a mixture of helium and neon gases contained at low pressure. It's about 50 Pascal and in a glass envelope. The energy of pump source of the lasers is provided by an electrical discharge through an anode and cathode at each end of the glass tube. The optical cavity of the laser typically consists of a plane, high reflecting mirror at one end and the concave output coupled mirror of approximately 1% transmission at the other end. The helium neon lasers are normally small, with cavity length of around 15 centimeters up to 0.5 meters, and the optical output power ranging from 1 milliwatt to 100 milliwatt. And how does the helium neon lasers work? And the work of this laser can be described in 4 steps. First, when the power is switched on, an energetic electron collisionally excites a helium atom to the state labeled by 21 SO. The excited helium atoms collide with an unexcited neon atoms, and the atom exchange the internal energy. So at the end of the process, we have the unexcited helium atoms and an excited neon atom. The excited neon atoms have the is written by neons 3s2, and this energy exchange process occur with the high probability only because of the accidental near equalities to excitation energies of 2 levels in this atom. So the purpose of population inversion is fulfilled. So the description of the energy diagram in the helium neon lasers. When the excited neon atom pass from metastable state or 3s state to the lower level 2p, it emits the photon of wavelength 632 nanometers. In this photon travels through the gas meter parallel to the axis of tube, and is reflected back and forth by the 2 mirrors of two ends of the lasers. So until it stimulates an excited neon atoms and causes it to emit a photon of 632 nanometers with the stimulating photon. So the stimulated transition from 3S levels to 2P levels is called the laser transition. This process continues, and when the beam of coherent radiation becomes strong enough, part of it escapes through silver ends of the laser, and it gives us a laser beam. The neon atoms pass to level 1S, emitting spontaneous emission, and finally, the neon atoms come to ground state through collision with tube walls and undergoes radiation-less transition. So, to make it easier to understand, we have prepared a video for you to watch and know more specifically how the laser works.
On the helium neon laser. We're going to be demonstrating it to high schools and other groups. It starts with your gas-filled tube down here, full of helium and neon. You have a discharge lamp that's going to send light into the helium neon, and it's going to excite many of the atoms, creating a population inversion, where most of the atoms are excited unless they're in the ground state. And so as they begin to fall, they're going to be spitting off light that's all at just about the same wavelength, because it's going to correspond to the transition from the helium to neon. So that light is going to go through the tube and out to a mirror that's located right here. And this mirror is going to reflect almost all the light back. And so the light's just going to continue going through the tube, exciting the atoms as it goes. And as the atoms get excited, they're going to very quickly drop back down and release more light. So by sending in the single discharge lamp from the side, you get a continuous laser. The laser is created from the little light that's not reflected right here at the end mirror, going out through and creating our image and our laser beam. All right, so as our laser is continuing and light is going through the tube, it bounces back and forth in slightly different ways as it goes. So the light comes in and it's not all together in a laser form. So it's bouncing throughout the tube and out to the mirror in a little bit of a different path. So as it gets bounced back, the path differences between the different paths gets a little more. And so by changing the mirror on the very end, changing the distance by just a little, you can get what are called different modes out of the laser, because you pick up and accent different paths. So as you can see, if I change the mirror distance by just a little bit, you can get a few very little, or you can get a more complicated pattern, such as one of these. And now that pattern is created just by interference between the different pathways going through the discharge tube. Now, as I've mentioned, we have our modes going through the laser tube. And as they go through, they're bouncing back and forth between these two mirrors, the adjustable one that we have here and the fixed one over on this other side. And now I'd like to show you what happens when we block a few of those paths as they go through. Now the laser has a bunch of different paths in it. So as I cover a few of the paths, the mode changes. Now I'm just covering a very little bit of the laser, not the entire thing. I can't keep too steady while I'm doing it. But you can see that the modes change because different paths are being blocked as I move the paper in front of me.
And if you block it completely?
If I block it completely, it's gone.
Đoạn này thì nó hơi nói bằng tiếng Anh thì hơi khó, thì em xin phép được nói bằng tiếng Việt cho nó dễ hiểu hơn. Thì mình dùng một cái nguồn ban đầu để mình kích thích cái nguyên tử neon, cái nguyên tử helium này nó đến trạng thái kích thích, và khi mà nó va chạm với một cái nguyên tử neon thì nó sẽ khiến cho nguyên tử neon này nó chuyển sang trạng thái kích thích, và khi mà nó rơi xuống cái trạng thái thấp hơn thì nó sẽ giải phóng ra một cái năng lượng, một cái photon có cái bước sóng như là cái bước sóng bằng với cái bước sóng mà cái neon này nó đã nhận vào, để nó tăng từ cái mức năng lượng thấp hơn đến mức năng lượng cao hơn, và do đó mà cái photon đấy nó chính là cái mà thành phần của cái tia laser mà lúc sau mình nhận được. Thì cái nguyên tử heli đấy nó phản xạ qua lại giữa hai cái tấm gương ở hai đầu của cái thiết bị phát laser đấy. Khi mà cái năng lượng của cái laser beam nó đủ lớn thì nó sẽ nó emit một phần qua cùng cái một tấm gương ở đầu của laser, và nó cho mình cái laser beam thoát ra ngoài. Đấy là cái nguyên lý hoạt động nó một cách đơn giản của cái heli neon laser này.
Okay. That's all of your presentation.
Yeah. So thank you also for watching.
Yes. Thank you very much, Đức Nam and Quách Linh Chi. Yes. Now for the time of question and comment. Who have any question for this presentation? You can continue the sharing to answer the question of everybody. Yes. Do you have any comment or any questions for this presentation? Now, please talk about your thinking. Diệu Quỳnh.
Thưa cô là em không có câu hỏi gì ạ.
Do you understand with the presentation?
Vì các bạn cho nhiều chữ vào nên là em đọc nội dung cũng hơi hiểu một tí ạ.
Okay. So the first comment is many character, not letters and letter figure.